Okay, everyone. Let's see, I'm gonna write down the time. It's 2:38. Okay, so I did not feel good about skipping this, and we kind of skipped over this that very first week. And this is something that could benefit you. Pythagorean triples are just kind of ways to know the missing side in a right triangle if you recognize certain patterns. So it says use the tools that you've developed thus far to determine the lengths of the missing sides of the triangles below. If you see a pattern that can be used, share it with your team. Okay, so to show your work on these, I'm going to ask you to draw these triangles. And I know some of you are going to moan and groan about that, but hey, it's not too bad. And I will be drawing them with you, so not too much to complain about if you're just drawing a triangle. So for 612 part A, we have a right triangle. All of these are right triangles. We have a hypotenuse of 12, and we have a 60-degree angle here. So we're finding the missing sides. Do you remember what, I know a lot of you didn't do special right triangles, and you know, it's not really the end of the world, but does pay off if you remember all these little shortcuts. Okay, so in a 30, 60, 90 triangle, we learned, this is what we were trying to do the very last day of school that we had, March 12th, I think. We learned that the hypotenuse is always double the short leg. So for example, in this picture, my hypotenuse, if my short, remember you have a hypotenuse across from the right angle, you have two legs, and the one that's across from 30 degrees is your short leg, and then this is called your longer leg. Okay, your hypotenuse is always double your short leg, and your longer leg is always your short leg times the square root of 3. If you only have one side in a 30, 60, 90 triangle, you can find all the other sides by using this pattern. And then in a 40, well, let's just go to our example here. So we are trying to find the short leg. This would be 30. So my hypotenuse is 12. So my short leg would be, did you guess 6? If you did, you guessed correctly. And then my long leg is just going to be that short leg times the square root of 3. So 6, let's see, 6 square root of 3. Okay, and I would recommend, yeah, you're going to be taking pictures, so, you know, try and fit what you can on one sheet of paper. Part B, we have a 45, 45, 90 triangle, and we have that a leg is, oops, 3. Okay, so let's draw that triangle. You've got two sides that are equal, making it isosceles, base angles are equal, so that's a 45, 45, 90 triangle. And whoops, we learned that 45, 45, 90 triangle, or you were supposed to. I feel like not a lot of people got the hang of this. 45, 45, 90, the two legs are equal. Well, you knew that already. And then the hypotenuse is the leg times the square root of 3. So we call the two sides that are including the right angle legs, and here you don't have a short leg and a long leg. You just have two legs that are the same, and the hypotenuse is whatever that leg is times square root of 2. So this would be 3, and this would be 3 square root of 2. Okay, part C, we have a scalene right triangle, and we don't know the angle, so we would just use Pythagorean theorem. If I use Pythagorean theorem, that would give me 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. So 25 equals c squared. And then take the square root of both sides, so c equals 5. So this hypotenuse would be 5. Okay, what do we have for D? We have another scalene right triangle. The legs are 6 and 8. If I do Pythagorean theorem with that, that's going to give me 36 plus 64 equals c squared. So 100 equals c squared, and c equals 10. So this would be 10. I'm just wondering, I kind of want you to be able to see all of this. I'm going to erase this, and for your work, you can just keep everything on the same paper, but I'm going to try, I probably should have started a new sheet of paper, but I think I can fit everything. I'm going to try and fit everything on this one sheet of paper so that you can see something after we do all of them. Okay, so this is 10. And let me get just an extra sheet of paper for the work. Okay, you don't have to fit all of this necessarily on one sheet. Okay, for E, you have a 30, 60, 90 triangle, and you have a short leg of 4. Oops. Oh. I'll draw it the same way it is in the book so I don't confuse anybody. Okay, so if this is 30, this must be 60. So if you don't have these nailed down, you can either take notes and make a little card like I have here, or these are summarized. Let me see, where are these? These are summarized in the math notes in lesson 613 in your ebook, or you could just pause the video and make a little card with this information. It really pays off when you're rushed to know these shortcuts. So if I'm looking at this, my short leg is 4, so then my hypotenuse is going to be double that, so my hypotenuse is going to be 8. And then my long leg is my short leg times the square root of 3. So my long leg would be 4 square root of 3. And these are fortunately easier than some of the ones you had on Con, where you had to rationalize the denominator. Okay, part F, we've got a scalene right triangle, and we know that the 2 legs are 5 and 12. So if you want to fit this on the same sheet of paper, that's fine. I'm going to do it separately. 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared. So 169 equals c squared. Take the square root of both sides, and the square root of 169 is 13. It's a perfect square. So my hypotenuse on F is 13. For G, we have, whoops, I went straight to doing Pythagorean theorem. Okay, we have another scalene right triangle. Legs are 3,000 and 4,000. So I'm going to do Pythagorean theorem. 3,000 squared plus 4,000 squared equals c squared. Now I could do all of that and write it out, but I know what's going to happen in the end. I'm just going to add those two together and take the square root. So I'm just going to type in my calculator. square root of 3,000 squared plus 4,000 squared is 5,000. So I know that this answer is 5,000. Okay, and part H, I've got two legs that are 36 and 15. Okay, let's do Pythagorean theorem. So 15 squared plus 36 squared equals c squared. That's going to be 225 plus 36 squared is 1,296. I'm going to take the square root of that sum. And it's 39. Okay, I'm just going to write c equals 39. Okay, and then we have a hypotenuse of 41. Okay, so I'm going to set this one up. 9 squared plus b squared equals 41 squared. Remember, c is always your hypotenuse. And that's going to give me 81 plus b squared equals 1681. I'm going to subtract 81 from both sides, which is going to give me 1600. Then if I take the square root of 100, b would be 40. Hidden information in this video is that I had a raspberry coconut latte for lunch today. I mentioned the latte on Monday, but I did not mention the flavor. So if you tell me the flavor when you send me your pictures, you will get some extra credit, so I know you were listening. Okay. So I know you're wondering, why are we doing all of this? So if you look at the next question, it says Carl noticed some patterns as he was determining the side lengths of the triangles in 612. He recognized that the side lengths in parts C, D, F, okay, C, D, F, G, H, and I were integers. I'm circling them in my notebook. And he also noticed that knowing the triangle side lengths in part C can help determine the hypotenuse in D and G. Okay, so let's look at that. Okay, he noticed that these are all integers, and remember from yesterday that, let's see, do I still have that up here? An integer is like -2, -1, 0, 1, 2. It's not going to be something that has an irrational number in it. So it's not something with square root of 3 or square root of 2. So he notices these are all integers, 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 and then he noticed that if he knew these three sides, then he could figure out these three sides, or it helped him figure out these three, and it helped him figure out these three. And there is a connection there that you hopefully will notice here. Okay. Groups of numbers like 3, 4, 5, and 5, 12, 13 are called Pythagorean triples. Why do you think they're called triples? So 3, 4, 5. If I multiply 3 by 2, I get 6. Isn't this just a dilation of this triangle? All of the sides are being multiplied by 2. Aren't all of these sides just multiplying 3, 4, and 5 by 1,000? So these are called triples because they're 3 integers or 3 numbers that when you look at them, they actually are the sides of a right triangle. So these are all triples here. And this may not make sense until we use them a few times. But these were just special right triangles. These you could figure out with the patterns that you were supposed to get from 30, 60, 90 and 45, 45, 90. Those, you should just know those or have a way to remember those or look up those shortcuts. But Pythagorean triples are going to be handy when you don't feel like doing all of this. You don't have to do Pythagorean theorem every time. You can just say, oh, 5 and 12, this is 13. Now this might be a little bit harder to recognize, but if you look at these 3 numbers, they're all divisible by 3. 15 divided by 3 is 5. 36 divided by 3 is 12. And 39 divided by 3 is 13. This is a dilation of this triangle. Okay, 9, 40, 41, that one's not in, but it is a triple. And there are more triples. If you just search up okay, let's get a good one. So I use these a lot because when I'm making a test or creating something, I want to come up with different versions. I just say, oh, I'll just use a triple. So here are some triples. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17, 9, 40, 41. Now those are the ones that I know right off the top of my head just because I've used them a lot. As they get bigger, I'm not going to remember them. And really those are the ones that come in the most handy. Okay, so let's work on 614. So you're going to be drawing these triangles. I know it's a lot of drawing, but that's how you're going to show your work on this one. Okay, so for part A, let's draw this triangle. We have a hypotenuse of 13. We've got a 30, 60, 90 triangle. So this is probably not a triple. We're just finding the missing sides. So this one's just a 30, 60, 90 triangle. So let's see if you can do this. In a 30, 60, 90 triangle, the hypotenuse is always double that short leg. So then this short leg would be half of 13. So this would be 6.5. And then the long leg is always the short leg times the square root of 3. So 6.5 square root of 3. Okay, part B. We have 2 legs that are 18 and 24, and we don't have any angle measures. Okay, so that means this is probably a triple. If it's not telling me it's 30, 60, 90, or 45, 45, 90. So what are both of these numbers divisible by? They're divisible by 3. 18 divided by 3 is 6. 24 divided by 3 is 8. Oh, wait, there's a bigger common factor. They're both divisible by 6. So let's do that. 18 divided by 6 is 3. 24 divided by 6 is 4. Okay, now you may not recognize it right away, but isn't that going to be 3, 4? Isn't it going to be 3, 4, 5? It's just a dilation of this triangle. So that means that this side would not be 5. This would be 5 times 6. So this would be 30. 30 divided by 6 is 5. So these are a little bit hard to figure out, but once you do enough of these, you'll start remembering them. Okay, part C, you have a 45, 45, 90 triangle with a leg that is 25. And I know this video is going to be a little longer, but Monday was short, 20 minutes. And I can't skip over this. It's helpful for next year. Okay, so 45, 45, 90. The two legs are going to be the same. So this is 25, and then the hypotenuse is just going to be whatever that leg is times the square root of 2. So 25 square root of 2. Okay, part D is a 30, 60, 90 triangle. Okay, are you starting to remember this? The hypotenuse is double the short leg. So this would be 14. And the longer leg is whatever that short leg is times square root of 3. So this would be 7 square root of 3. Okay, so no triple, just using our patterns. Okay, for E, we have a hypotenuse of 52 and a leg of 20. Okay, so this is probably a triple. So what goes into 20 and 52? What's the biggest number that they're both divisible by? Now you may not think of this right off the bat. You might say, oh, I know they're divisible by 2. You can do it that way. You can say 20 divided by 2 is 10, 52 divided by 2 is 26, and then still you might say, oh wait, those are divisible by 2. So 10 divided by 2 is 5, 26 divided by 2 is 13. Or you might have known that 4 is the greatest common factor for 20 and 52. So it's up to you how you want to figure this out. 5 and 13, that is a triple. A leg of 5, a hypotenuse of 13, that means that other leg is going to be a multiple of 12. So this is the one we're working on, is just a dilation of this triangle, 5, 12, 13. So this is not 12. Can you figure out what this would be? It's a dilation of that triangle, so 5, so you can maybe even draw the little one in the middle. 5 times what is 20? 5 times 4 is 20. 13 times what is 52? 13 times 4 is 52. So you know this is going to be a multiple of 12. 12 times 4 is 48. So this would be 48. You're just multiplying by 4. Okay, F, we have a hypotenuse of 6, and it's an isosceles triangle. That is a 45, 45, 90 triangle. So my two legs are going to be the same, and my hypotenuse is going to be whatever that leg is times square root of 2. Oh, this one is a little bit harder because it's giving me the hypotenuse and it's not 6 squared of 2. It's just 6. So we're going to go backwards and we're going to say 6 equals x times square root of 2. And then we're going to get x by itself by dividing both sides by square root of 2. So that's the answer. Con doesn't let you put that in. Let's write this out because not everybody did special right triangles. This might be the only time some of you are seeing this. So I'm multiplying by square root of 2 over square root of 2 because con, other math teachers are going to say, sorry, you need to rationalize the denominator. And that just means you need to write this without an irrational number in the denominator. So I'm multiplying by square root of 2 over square root of 2 because square root of 2 times square root of 2 is square root of 4, which is 2. You get rid of the irrational number in the denominator. I have square root of 2 in the numerator because that makes this fraction 1. And when I multiply by 1, I'm not changing the answer, I'm just changing the way it's written. So that's going to give me 6 square root of 2 over 2, and 6 divided by 2 is 3, so I get 3 square root of 2. Okay, let's see, that was 2:30, so 2:40, okay, I'm looking at the time. I'd like to wrap this up today, so can you try doing 6-15 on your own, or Diana looks at the problems below and thinks she cannot do them. Eric points out that they are related to the previous triangles, but instead of numbers, each side length is given in terms of a variable. Use Eric's idea to help you write expressions for the missing side lengths. These are actually pretty easy. Let's try and get these done, and then we'll stop after this one. Okay, so for 6:15, we have a 45, 45, 90 triangle with a leg that's x. So then what would this leg be? This would be the same, right? So this would be x, and then the hypotenuse is always, this is exactly like the card that I had on the screen, x square root of 2. Okay, for part B, you have a 30, 60, 90 triangle. And y is the short leg. So your hypotenuse would be, can you figure out what this would be? 2y. It's always double that short leg. And then the long leg is the short leg, y, times the square root of 3. And it's hard to remember these if you're not using them all the time. The reason I know these so well is because I had to use them all the time. So that's why I wanted us to do more practice this week than learning more new things. Okay, so 3x and 4x, what would this be? Well, that's a triple. That's the most common triple, 3, 4, 5. If you see a right triangle and you see two of these values and they're in the right spot, 5 would have to be in the hypotenuse spot, 3 and 4 would have to be in the legs, then you know the other sides without having to do Pythagorean theorem. You know this is 5 times something. Okay, part D is 5x and 12x, so that's a triple. We just used this. Okay, so 5, 12, 13 is a very common triple. I'm not going to do Pythagorean theorem when I see this. I may not recognize it right away, but if I can save time, I'm just going to do that. Okay, and then for E, you have a 30, 60, 90 triangle. And your hypotenuse is X. Hypotenuse is double your short leg. So your short leg is half of your hypotenuse, and then your long leg is whatever this short leg is times the square root of 3. So this would be X over 2 times square root of 3. Okay, send me pictures of your work with that hidden information and you will get some extra credit.